Today's lesson is 1.3, Similar Triangles. The learning goals for today are to identify similar triangles and to use the properties of similar triangles to solve for missing angles and or to solve for missing sides. Similar figures have the following two properties, and I say similar figures even though we're going to be focusing on similar triangles. So it could be similar squares or similar diamonds, but we're going to focus on triangles. Similar figures always have corresponding angles that are equal, that are the same size, and then corresponding sides that aren't equal but are proportional. So it's just as if you've enlarged or reduced the shape. Same size, same shape, but the sides are different, but they change in a way that is proportional. In this example, we don't have a diagram. So the first thing we're going to do is we're going to draw our own. So you have to draw a triangle PQR, and it says at the top there that it's similar to, and that's what that symbol means. It's a squiggle, no equal sign, similar to, triangle, LMN. Notice I tried to draw just a bigger version to show that it's been enlarged. Okay, and the way I drew the triangle is very careful to make sure that the corresponding angles were listed in the same order. And then what you can do is also list the corresponding sides as ratios because the sides are proportional. So PQ matches with LM, and QR matches with MN, and PR matches or corresponds to LN. You can see that in the picture as well. PQ corresponds with LM. PR corresponds with LN. QR corresponds with MN. Okay, so from the picture or from the statement at the top, you can write out this proportionality statement with all 6 sides. Also, don't forget to fill in the numbers. So we have a side length of 4 units, 9 units, and 10 units based on the information we're given in the question. Fill that in your 6 proportionality, in your 3 proportionality statements with all 6 sides. Some of them are still unknown, so we don't know LM, PR, or LN. We'll just leave those there. And when you're ready to solve, remember when you're solving a proportion, you have 2 fractions that are the same. They're equal to each other. So what you need to do is look for a pair of fractions that has 3 given values and 1 unknown. And we're going to label the unknown X. Okay, now you can just cross multiply and divide like you normally would. So we have 4 times 10 divided by 9. That approximately equals, I put the dot on top of the equal sign, 4.4 units. That's rounded to 1 decimal place. In the second example, we have the picture, but we don't have a statement of proportionality. We don't actually know, a statement that they're similar. We need to prove they're similar so we can come up with our statement of proportionality. We do see opposite angles, so we know that on both sides, angle R is the same size. Angle R equals angle R. You'll also notice that there's these little triangles on each side there, showing that the sides are parallel to each other. So we can come up with a Z pattern showing alternate angles. So angle P is equal to angle S. And you can also see then that angle Q is equal to angle T. They're also alternate angles. The Z pattern because of parallel lines and transversals. Okay, because of that, we now know that the triangles all have the same angles, and from the definition, we remember that if the angles are equal, then we have similar triangles. We're going to list that triangle RPQ is similar to triangle RST. It's important that you put it in the correct order. Okay, and we're going to take that list and we're going to make our proportionality statement. That side corresponds to that side. The next two correspond to the next two. PQ and ST. Okay, and the last pair we haven't listed is RQ corresponds with RT. Notice everything from one triangle is listed on the top, everything from the other triangle is listed on the bottom. The order doesn't matter as long as you have all three. Okay, once you have that statement that all three fractions are equal to each other, you're going to take the number values or the letter values from the picture and replace them in the statement. So y over 12 and 15 over x and 27 over 18. And to solve, remember, you only need two fractions equal to each other, and you need to have three given values and one unknown. So we can start by solving for x using these two fractions, this pair of fractions. 15 over x equals 27 over 18. Cross multiply 15 times 18 and then divide by 27. And then we get an answer, x equals 10 centimeters. Okay, and I just want to show you that the ratios don't have to be side by side. We can use y over 12 and 27 over 18 since they're all equal. We just have to make sure we have three number values and only one variable, one unknown. And cross multiply like before, 12 times 27 divided by 18. Okay, by calculating that, you can do it all in one step. Y equals 18 centimeters. Don't forget the units at the end. It's important because this question is all about centimeters.